All right, so when you have rational equations, the best thing to do as soon as possible, try to multiply by a common denominator, okay, throughout the entire thing to alleviate those fractions, all right? It's going to be kind of a pain in the butt in this one because we have, what kind of fraction is that on the left? We have fractions inside fractions, compound fractions, okay? So it provides basically an extra step here in the long run, but if you look at this, if this was just like, let's say we had, I think there's a question earlier maybe I did something like this. If I had just, let's say 1 over x plus 3 is equal to 12, okay? The best thing would just be multiply every single term by x. Eliminates the fraction, right? Okay. So we multiply by the denominator. Well, in a compound fraction, we have multiple denominators, but the overall denominator right away is that. Let's try to get rid of that. So kind of multiply both sides by that denominator, yeah. So just kind of being explicit with what we write here, we're going to go 1 plus 4 over x is what we'd be left with. We multiply the left-hand side by that denominator. And then the right-hand side becomes, we have the x, and like I said, explicitly showing that we have the 3 minus 2 over x. Okay. Still kind of ugly, but if I distribute that x through on the right-hand side, it gives me 3x minus 2, correct? 2x over x, and cancel out, we just get minus 2. On the left-hand side, now it's kind of generated down to that example I put up there, right? Where we multiply both sides by, again, that common denominator. The common denominator here is just x, right? The only thing you got to be careful with here is that a lot of people forget to do this. You can't just multiply the things that you want to multiply by x. You got to multiply everything by x. Okay? So I'm going to multiply the 1 by x, the 4x by x, which gives me 4. On the right-hand side, then I get 3x squared minus 2x. Okay? And that, just because the section we're in, that might kind of jog your memory, so yeah, I'm probably doing things right because I just got a quadratic, right? We get quadratic, we want to solve, or set equal to 0 and solve, right? So I get 0 is equal to 3x squared. We'll go, what, minus 3x, and then minus 4. Remember going through our hierarchy of trying to factor quadratic equations. First thing, see there's a GCF and everything. Okay, so, and it doesn't necessarily, we talked about it the other day, just trying to divide by A. Well, it doesn't just have to be A. Obviously nothing, for all three parts are not divisible by 3 there. But say that they were all like multiples of 2. Maybe they were like 6, 6, and 8, right? Well, I can bring a 2 out, make it 3, 3, and 4, and it's going to make my work with quadratic formula a little bit easier, right? Okay. So regardless of whether I can make that a 1 or not, still see if there is at least something that will factor out of everything as a GCF, just to make your future calculations just a little bit easier. But nothing works there. So the next thing is with this not being able to go to 1, when we go to the factor by grouping or the A times C method. So we're getting negative 12, right? I multiply 3 and negative 4. And I'm figuring my factors and multiply together to give me negative 12. Do any of those add up to give me negative 3? No. Okay? And then hopefully these are processes that you're going to go through pretty quickly, all right? So where I don't have to do a lot of laborious work to really go through GCF, factor by grouping AC method, and now ultimately what do we have to do if none of those work? Quadratic form, okay? The hope is to realize that the other methods are probably maybe a little bit quicker. They're a little bit cleaner to deal with, but the quadratic formula, if you want to go at any time, go straight from a quadratic equation to quadratic formula, by all means feel comfortable or feel free to do that. There will be times maybe that's a little bit more cumbersome than you want it to be, but it will always work. So your opposite of b, b squared, 4ac, all over 2x, equals 6. So now we get 3 plus or minus. Now inside there we get what, 12, 48, so 9 plus 48, it's 57. Over 6, now 57 prime, isn't it? Okay. So, can I divide these two things in? We can. Okay. But now here's the issue. If I'm going to divide those two things, I can't just rewrite this as, I divide them out, it gives me a 1 here and a 2 there, right? Okay. I can no longer write that in the format that we currently have. And I'll kind of show you why. We know that we've got a sum or difference up top, right? All over one fraction. So we're going to rewrite that as 3 over 6 plus or minus. This is positive 3 negative. Positive. Okay. 3 over 6 plus or minus radical 57 over 6. Okay. Now those cancel and give me 1/2, right? Plus or minus radical 57 over 6. Okay. What people want to do is this and get 1 plus or minus, leave it as radical 57 over 6. Oh, not 6. 2. Okay. And then if I separate that, I get 1/2 plus or minus radical 57 over 2, which is not the same as what we have here, right? On equal statements. So if you are going to cancel terms like this, perfectly fine. We want you to reduce. But understand that you cannot write this as this kind of condensed version unless all 3 coefficients have the same factor inside. Make sense? Okay. Just a small kind of notation thing that we got to talk about. That's looking into web assign. That's what they're asking typing in as. I'm assuming if you would have typed it in that way, they would have been okay with it. I don't know. Is there a plus or minus? You got to type in both. But if you type it in as 3 plus radical 57 over 6, is it okay? Accept it. When you see their solutions are kind of like this. See where they factored the 1/6 out for us. And they didn't even, here they didn't even, because 1/6 times 3 is 1/2, so they didn't even simplify there. But not a big deal. If you would have got if you would have got a square root here that has a negative discriminant underneath it, okay? Or if your discriminant was negative, that would be no real solution, right? Hopefully we still calculate those, but they're really not really interested in knowing what those solutions are. They just want you to identify them as real or non-real. There's another one on there that was similar to that. Question 4. Okay. Similar style question. That's not a compound fraction anymore on the left-hand side. It's just a sum and difference of fractions. But we have to find a common denominator, right? Okay. Now, something that you guys have talked about in the past is finding least common denominators, right? When you have equations like this, for instance, if I had, let's make it really easy. Let's get rid of all the variables in the denominator. So if I had like 1/2 x plus 2/3 equals 1/4. Okay. Least common denominator there would be what, 12? Okay. I can make the small. Basically, when I say LCD, we're thinking about what is the smallest number I can make all those denominators grow to through multiplication. And 12 would be that first number we get them all together to, right? Okay. Strictly through multiplication. Now, if you can't visualize it, you can't see that 12 was the smallest. Can I take 2 times 3 times 4, times 4 and get myself 44? And will that work? Yeah. It'll work, but what's that do to my numerators? It makes them bigger too, right? So if you're comfortable working with those larger numbers, that's fine. The only thing that we want to draw kind of comparison back to this is if I don't use the LCD here, and it's really not that, I don't think, hard to do here to recognize what the LCD is going to be, or if we do this correctly, the equation that we develop should be a quadratic. Okay. If I don't use the correct LCD when multiplying by variable terms to make a rational equation a little bit easier, I might force my final equation that we're going to solve with a factor to be in a form that's maybe more difficult to factor. Instead of and if I were to multiply here by x squared times x minus 2, okay, my resulting quadratic would be to the third power. Factoring the third power or polynomial is a little bit harder than factoring a quadratic polynomial. Does that make sense? So if I incorporate extra variable terms, it's just going to make my formula, my equation, when you have higher exponents, and the higher the exponent, the more difficult it is to factor. Okay? So we want to be cautious to make sure that we get the least common denominator with these. Eventually, when we learn the rational root theorem at some point, what chapter, maybe chapter 3, we really won't care because there's kind of a default technique for finding those solutions. But right now, we're going to pay attention to finding the least common denominator. So least common denominator, we can make this one, that one, and this one here all grow to x times x minus 2, can't we? Okay. And that one's a situation where if you couldn't recognize that, that one is you take every single denominator, put them together through multiplication, you've got your common denominator. Okay. Couple different ways of writing this. We'll just write this out kind of the longest way so you see the theory and the logic of why we can do what we're going to do. I'm going to multiply every single term by that. Okay, so what we need to realize is I am now trying to take this fraction of 21 over x and rewrite it so it has a denominator of x times x minus 2. Minus then, okay, here, we're trying to make that denominator go to x times x minus 2. Now, this is probably something most people would not write as they're doing these problems. Don't go before that. X minus 2, and then x minus 2. Okay? I'm trying to get every single denominator to grow to that, right? Okay. So if I make this initial denominator grow that, what did I have to multiply the bottom by? X minus 2. So I multiply the top simply just by my x minus 2, right? So I get 21 times x minus 2. We'll evaluate that here in a moment. Come over here, same idea. Okay, I had to multiply this. This was my common denominator. I multiplied ultimately that by just x, right? Okay, so we get 35x. Top, okay. And then on the 4, we're going to multiply by everything. 4x times 2. And then the right-hand side, I had to multiply this denominator of 1 by everything. So we get 0 times x minus 2. You can say a little bit right back. But that's what we ended up with, right? Okay. Now, like I said, most people are not going to write it that way. This is the reason why we can do kind of the shortcut. What do you recognize that all the denominators are now? The same. And if all the denominators are the same, does it matter whether I deal with them or not? Like for instance, if I had 1/2 equals x over 2, what do you know that x has to equal? 1, because the denominators are the same, right? So once we develop all the denominators to be the same, we can kind of shortcut things and just end up with 21 x minus 2 minus 35x plus 4x x minus 2 equals 0. All right. Now you can go through, I'll leave this for you guys to finish on your own, and now you can go through, multiply that out, eventually factor, right? And if you look at this, the highest power you're going to get is right here when we get the 4x squared. And hopefully at some point we can maybe bring some factors out and make the quadratic formula or your factor techniques a little bit simpler. Okay? But like I said, most people aren't going to write it that way. Most people are going to say, okay, I know that my common denominator is x minus 2, and they go through and then just write. This is what I always do. I think it's the safest thing to do. And you can do it here as well. Kind of trivial to do it there with the 0, but you write that common denominator with each one of those terms, and now we just say, okay, those are going to cancel. So it leaves me just with 21x minus 2. Those two are going to cancel. Leaves me with just minus 35x. Nothing here cancels, so it leaves me 4x, x minus 2, and obviously times 0 gives me that 0. And we develop that very quickly. That makes sense. It saves a little bit right. But that's the logic of why we can cancel those that way, because ultimately we're creating the same denominator every single term. So the denominators are all the same. The numerators are now allowed to be added, subtracted, whatever we have to do. Is that okay? All right, so finish that one up. Those are the two that I were concerned with kind of doing with you. Are there any others that you guys want to talk about? 8. Find all real solution of the equation by completing the square. All right. So they said by completing the square, perfectly fine. Nothing wrong with that. But what sucks about completing the square? Yeah, it takes a long time, right? Does the computer ever know whether you complete the square or not? Nope. Okay. So if you want to complete the square with this, by all means do it. Not a task that we shouldn't be able to do. There will be times where it's going to be, if you remember back to earlier in the chapter, we dealt with some stuff with circles where we had the concept of procedure forced us to have to be able to complete the square. But in this task, we're just solving an equation. If you want to complete the square, go ahead and do it. Use quadratic formula. You can use quadratic formula. Quadratic formula is exactly the same as completing the square. Okay? So it doesn't really matter the route you go here. What I would do, just to make things easier, especially if you are going to complete the square here, use the quadratic formula, I would take a factor of 2 out. So I'd have 2 times 2x squared minus 8x plus 7 equals 0, right? And this is where people get confused a lot of times, and when a GCF can disappear, and when we have to keep it. If it's an equation, right now that GCF of 2 can disappear, because these are two things being multiplied together, right? And this is, we're putting this in parentheses, so we're saying that's one term, right? So 2 times the term is equal to 0. The next thing I would do is divide both sides by 2, right? So you divide 0 by 2. Yeah. So we end up with 2x squared minus 8x plus 7 is equal to 0. And that's where that 2 can disappear when we factor that out. If it was strictly just an expression without the equal sign, that 2 has to stay. Does that make sense? Because we don't want to change the expression. We don't want to change what it does to particular values of x. But now we can go ahead and, if you're going to use a quadratic formula, we're going to go the opposite of b, so 8 plus or minus b squared minus 4ac all over 2x. And remember, that's what x is now equal to. All right? So evaluate that. We got 56 here. So it's going to give me what? 60, so 8 plus or minus radical 8 all over 4. I would simplify this before I start canceling, because 8 square root of 8 is 2 radical 2, right? So now there's a factor of 2 in all those, we cancel out. When I cancel out the factor of 2, this is something I see a lot of times. Can I cancel that factor of 2 out? Put the 2 into the denominator? No, it's locked inside that radical, so we can't touch it. Okay, so you're just going to the 8 divided by 2, and then 2 divided by 2. So you should get 4 plus or minus radical 2 over 2. All right. Now that's using ultimately the quadratic formula, but we talked about how the quadratic formula was developed by taking the quadratic equation ax squared plus bx plus c equals 0, completing the square of that, right? So now with a, b, and c being 2, negative 8, and 7, we're good to go. Come on. Say again. have the exact same numbers I do? I'm known to make mistakes, so 8 plus or minus b squared 64 minus 4, a, c, that's 56, 64 minus is 8. Check to make sure you're starting with coefficient. Good. Now, since it does say using completing the square, we can do that, but you start to see maybe a drawback from actually following those directions. If I go 2x squared minus 8x plus 7 is equal to 0, right? Yeah, that's what we got when we factored that GCF out. First thing completing the square is to get, and they're independent steps, so you can do them either order first, or you can do them together. But we need to make that a 1. So we divide everything by 2. And now we're going to take the c term and move it to the other side, right? Okay, then the development of that 7 halves kind of maybe makes things a pain in the butt for us, more than maybe quadratic formula. Okay. You're going to take half of that and square it, so it gives you 4 here. And you're going to add 4 over here, which is just, I'm going to rewrite it as 8 over 2 to maintain that fraction, right? Okay. Remember that this provides us a perfect trinomial. It's always going to go to x minus half of that term with its sign. And now over here we get what? 1/2? Okay. Take square root of both sides. So when I get x minus 2 equals plus or minus radical 1/2. Okay. Which, just to maintain kind of the units that they want, rationalize denominators, that kind of stuff, radical 1/2 multiplied by radical 2, it's going to give me radical 2 over 2. And I'll add 2 to both sides, so x is equal to 2 plus or minus radical 2 over 2. Which should be the same, is that the same as, I erased it. What did I have earlier? I had 4 plus or minus, we have 2 radical 2 over 2. And then if you cancel things correctly, we get the same result. Just be aware of the different, that's one of the things that I really want us to understand in this class. It's not, can we calculate these things? Can we do the arithmetic and all that kind of stuff? That's important. I want you guys to really understand when is it appropriate to do one technique over the other, and at certain times when is one technique the exact same procedure, the exact same process as a different technique. So when you use the quadratic formula, I want you guys to know that's exactly the same thing as completing the square. So if you're on a test, and the test that I give you, it will say use the quadratic formula or use completing the square. If you're intelligent enough and you understand that they're the same thing, then you should be able to argue. If you go to one on a test, and whether it's for me or another teacher at some point, and they say complete the square, but you use quadratic formula, and they might be wrong because you did the incorrect process, they'll argue to it. Say, hey, quadratic formula is exactly the same thing as complete the square, right? You have that logic, you have that argument, and you should be fine. And that's, I want you to understand the ins and outs, the theory of mathematics and stuff like that, because it allows you to adapt yourself to solving maybe a different